I hate the beginnings of YouTube videos. They're often extremely repetitive. I especially loathe those infantilizing creators who think that saying that they hate the starts of YouTube videos excuses them from finding a good hook. But here we are. I love Love2d. Love2d is a C-based framework developed for the interpreted programming language Lua, which enables you to work with low-level graphics. Everything from platformers to card games are developed with Love2d, but I myself am partial to designing my own 2D simulations. My friend Tyler and I spent a large amount of time in our junior years of high school searching for an option for low-level game design. We wanted something that would enable us to code our own mechanics with more control and comprehension without all the bells and whistles of Unity and Unreal. While those are incredibly powerful tools, I wanted to get a fundamental understanding of how games ran frame by frame rather than node by node. The best way I can demonstrate Love2d is by first installing it from the website, grabbing a shortcut to the executable, popping it on my desktop, making a folder with the first file being titled main.lua, writing this line in it, and then dragging the folder into the shortcut that I just made. For those of you following for tutorial purposes, I apologize if that was hasty. I am mostly intending to talk about something that I enjoy, not walk you through an installation process. As you can see, a beautiful, juicy, black window appears with the most sensual, tantalizing, and spectacular text, "Hello World." From here, all you have to do is go to their wiki, learn how to make shapes and shit, code your own kinetics and metatables, and voila, you have functionalism. A couple weeks ago, I experimentally uploaded a demo of one of the programs I've made. It's all about balls. I actually managed to get a comment asking about them, so I decided to make a more intimate video about my orbs, while also simultaneously showing off Love2d. Fair warning though, I'm a major league amateur who's way too egotistical to apply things in a manner residing outside my own fuckery and intuition. My apologies if that's frustrating, but that's why I'm going into biochemistry and not computer science. AI's taking both jobs though, so who's counting at this point? But why balls? I really like physics. Despite not having any interest in the pretension and competition, I think that it's so admirable that we, as a species, have been able to quantify our universe to an extent that even slightly resembles our reality. As a result, when I have the fleeting spurt of programmatic inspiration, I'll make my own physics engine from scratch. Now, in order to demonstrate Love2d in all its glory, let me guide you through its deliciously prepared innards by giving you a tour of my program of balls of all sizes and colors. This first section of code is what I like to call BS, boilerplate shit. This is where I set up various varying volatile variables as voluptuous, vigorous globals. Yes, I use globals liberally. Eat me. This helps make accessing them down the road easier. Next, this function is where the magic of Love2d begins. You'll notice that I'm referencing a previously undeclared member function of a metatable, and I'm sure there will be a pedantic commenter correcting me stating that it's actually a mega discombobulatory syntax hyphen or something arbitrary and soul-sucking, but I don't have the time to listen. Normally, if you run Love2d without anything, it shows this delightful screen. I'm actually not totally sure what the branding schema was here, but I guess it's cute. Anyway, when we're overriding the function, it actually changes what Love2d will do on its first frame. The same will go for any other function that we change. Later, you'll see that we adjust the functions love.update and love.draw. These are going to be where most of the fun stuff is. Now that we have an idea of how the program knows when to do what, let's look into what I'm trying to instantiate during this load function. I set up the window, created a table to load up with particles in a generic little for loop, each with random mass bounded by the earlier values prior to the load function. I also have some other variables inherent to each particle that will be used later during collision, velocity, and drawing updates. Simple enough. Now here's where my favorite parts of simulation design lie, the update function. This is where we handle all collision, velocity, and position updates. Well, most of them. First, I like to check to see if any of my balls are dragging off the screen. This would, hypothetically, eventually, cause a most testicular computational ruckus. Since there's no real reason to allow things to move off the screen into a binarily derived infinity, I like to make fully elastic collisions the way of life. This is also because rendering semicircles in Love2d seems like a pain, and Occam's razor says that an asteroid-style scrolling map is going to break my will to live. Occam's razor doesn't actually say that, I do. In order to see if the screen is clipping my balls, I need to ensure that the radius of each ball doesn't extend before or past any window bounds. This means if statements, and 4 of them to be precise. I'm sure I have some Boolean wizard out there that would crucify me for it, but this has been the best way I've identified to call collision events when one of the balls hits at the edge of the screen. For those of you interested, I'll display a diagram of how the logic works. And yes, I made this in Google Slides because graphic design is for wannabe hipsters. No shade, graphic designers, most of you are chill. Except you, Emma, you haven't gotten back to me about my playing game. The last part is applying a dampening factor, which I have set to 1 because breaking the laws of thermodynamics is what simulations are supposed to do. I also ensure that none of the particles are moving at ridiculously slow speeds because for some reason that caused them to stick to the edges of the screen. Now this is where the most of my clusterfuck resides within my balls. First, I want to acknowledge that it is probably a horrible form to check each of my balls for penetration within the draw function rather than the update function, but it's working right now and I'm too cowardly to change anything yet, so deal. Secondly, yes, my variable names are weird. Deal with that too. And thirdly, I actually don't care about your fancy-ass proximity optimization, okay? Please don't start with me. Anyway, I've got a for loop iterating over all the balls. Within that for loop, we have another loop that is doing a hell of a lot of math to identify first, how close the balls are, and second, if they're touching, how to make them bounce off one another. No one likes sticky balls, so getting this math right is important. We need to first identify how far away each particle is from one another. This lets us tell if they're closer than the sum of their radii, or in layman's terms, if ball touch other ball. If they're not, thank God, we can spare some computational power and skip the iteration. Otherwise, we do math identifying how they collided and how the resultant velocities behave depending on their mass. I don't know if this video should be about that process, and I altered it a little bit so I don't have to fuck around with vector math, but I don't think that it totally works anyway, so I'll have to refer you to a most delightful video by the eloquent Reducible. I honestly loved his explanations, and he did a wonderful job with Manum, something I'm also too cowardly to explore. I found his reference to Vivarian.com's paper on two-dimensional elastic collisions without trig particularly helpful, but I am still so curious how they got it algebraically. I'm not that great with systems of equations, so if anyone can write me a proof, I promise I'll make more ball play videos. Lastly, we have the actual draw function. This loop simply goes through all the balls and draws them. Now that I think about it, it very well could be placed within that previous loop updating the collision of all the balls, improperly placed within the draw function, but that's why making these videos are so fun. I have no idea what I'm doing, and that highlights this so humbly. In order to wrap this up, long story short, most of this code was math that I had to design on my own. It took loads of critical thinking, quite a bit of research, collision techniques that I still don't fully grasp, and patience that I didn't think was worth having until I realized it was working perfectly. I have more programs that I'm prouder of made in Love2d, but I thought this was a good demonstration of what I like to do in it, and hopefully an inspiration for those who are looking for a lightweight frameworks for your own personal experimentation. I know that's a little dated, not the most powerful framework out there, and can feel a little clunky at times, but there are so many opportunities for prototypical work and the power to keep it as simple as you want. I love its flexibility in terms of how you want to render the screen, its built-in physics module so you don't have to do what I just did, its extensive documentation in forums, and its tendency to just make me feel so fulfilled anytime I do get something to actually work. I've had a lot of affection and care for the software, and I think you should too. I'm sure that something out there outshines Love2d in terms of elegance and reliability, but in the meantime, I say keep giving your love to love and go play with some balls. Okay, and this is a little Candid Credits scene because I haven't made a YouTube video in like over 2 years. Special thanks to Tyler for showing me Love2d. Thank you to The Bean for helping me figure out how to like animate all this stuff and narrate it. And then I have a lot of the sources for different images, sounds, information that I used in the description, along with a whole bunch of timestamps and whatever, you know, you'd normally see in the professional YouTube videos. I hope this was fun to listen to, and I appreciate you watching.